To now show the effect between a hydrophobic and a hydrophilic surface, we're going to put a droplet of water on a piece of parafilm and on a glass slide. And there you will be able to see the difference between a hydrophobic and a hydrophilic surface. So first the droplet on a hydrophobic surface, which is the parafilm. What you might be able to notice now is that the angle that the droplet makes with the surface is greater than 90 degrees. It's called a contact angle, and that is indicative of a hydrophobic surface. Now we're going to place another droplet on the glass slide next to it. Here it comes. And what you can now easily see is that the angle of the sides of the water droplet that it makes with the surface is much smaller than 90 degrees, in this case about 45 degrees, indicating that this surface is hydrophilic. Now this is also what you have to look for when you apply a droplet of water to your EM grid. And we're now going to show the difference between a glow discharged and a non-glow discharged EM grid. So now we have two grids, one that has been glow discharged, which is this one on the right side, and one that is coming straight out of the box. We're going to apply a droplet of water and see what happens. So here, the one that is not glow discharged that comes out of the box, we can clearly see that the droplet has a very large contact angle, therefore is hydrophobic. If we now apply a droplet of water and then on the glow discharge grid, we can clearly see that here the contact angle is again 45 degrees. And if we now come with the filter paper, we can see what the effect of blotting will be. So if we would blot a droplet on a hydrophobic surface, what you might notice is that you can take the full droplet clean off from the surface in such a way that the surface is actually, like so, completely dry again. So the danger that you have is when you have a hydrophobic grid and you apply a droplet of water and you then blot, you blot away all of the liquid and you do not end up with a film. Whereas if we go to the hydrophilic grid on the other side and we blot on that grid, you might be able to see, especially from the top view, that the grid will remain wet. So the hydrophobic grid is dry while the hydrophilic grid looks wet. That means that the hydrophilic grid has a film and all the holes have been filled with a thin layer of water, while the hydrophobic grid can be completely dry and empty. This is the reason why we have to glow discharge the grid before we use it, to make it hydrophilic, so that we can create a uniform layer of water solution with our proteins inside.